Good morning, children. Today in this session, I'll be continuing the electricity chapter and we will be studying about the color coding of resistances. As we studied yesterday, that resistances provide a very important role in electronic circuits because wherever we need a desired voltage or a desired current, that can be achieved with resistances. Now the question is, how do you calculate the resistance or the resistance path? There is a specified way for it which I am going to tell you today. Okay, for example, let us see that this is a resistor which we often get from the market, having two ends with the wire. Then we have, this is one spark line, the second spark line followed by a third line. These are some lines which you see on the resistances, and these are providing color. Followed by, there are two more lines at the other end. Okay, now let us name this as A, this as B, and this line as C. Now you will be wondering how this can be, we can assume the values. Okay, now the formula for calculating this is A B into 10 to the power C. Now this is not A into B. Okay, this is not A into B. This is just the ones place and this is the tens place. Okay, now the third, whatever we get the reading, it has to be given in the exponent of 10. This is the formula being used. Now we see there are various colors which are there in the resistances, and from that we can verify what sort of resistance is that and what is the value. You also wonder, what are these two lines for? These two lines are for the gold and silver band. These are two bands which shows you the tolerance which this resistance can have. For example, if it is having a gold, it offers you a 5% tolerance. That means if the maximum voltage which can be given to this resistor is 1 volt, this resistor can operate plus minus 5%, that is 0.5. That means 0.95 volt to 1.05 volt. The silver offers 10% plus minus 10% resistance. Okay, so we will first of all see the tolerance. Tolerance. You have a gold band which gives you plus minus 5% tolerance. Next you have a silver band which provides you with plus minus 10% tolerance. But on the contrary, if you do not have any kind of band, that doesn't mean that the resistance is not having a tolerance. Okay, if you have a no band, means there is no band, then that means there is a plus minus 20% tolerance. For example, if we have the maximum voltage is 1 volt, say coming, or let's do with 1 volt. So if we are using the no band, that means it is having a tolerance of plus minus 20%. That means the range for this is 0.8 volt to 1.2 volt. This is the range within which this resistor is going to function. Now the question is about your color coding. Okay, now for the color coding we have a formula which is states as because it is very difficult for us to just remember the colors along with the coding. So it states as P Roy of Great Britain had a very good wife. Now you will see in this sentence, B.B. Roy of Great Britain had a very good wife. You will see that I have put some capital letters in some of the spellings and followed by small letters. So these capital letters you underline, and these gives you the color coding. For example, we start with B. This is black. Then the second B. This is brown. Then we have red. Then O stands for orange. Now the color coding, we start as black stands for 0, brown stands for 1, red stands for 2, orange stands for 3. Then we have white, that is yellow. Then we have G. This G is for green. This V is for blue. Then this V is for violet. This G is for gray, and this W is for white. Okay, now we reach up to 3. The yellow gives you color coding 4. This gives you 5. Gives you 6. This gives you 7. This gives you 8, and white gives you 9. Now these are the color codings for the resistances. Now, for example, if we want to calculate a resistance, how are we going to do it? Okay, now we will see. For example, we are having the first, second and third color as say brown, black and say green. So if we have brown, black and green. Now how does it work with the formula? Brown. What is the color code for brown? Is 1. We will follow this particular formula. So A is 1. Then we have black. Black is 0 into 10 to the power. What we have? Green. Green is 5. So this is coming out to be 10 to the power 6 ohm or 1 mega. In this fashion, we can very well understand what sort of a resistance we are having and what is the value. So accordingly we can calculate, and in that context we will be needing various kind of resistances for our various kind of circuits, and we can calculate the values and then put the desired value in the circuit. If you have studied the today's lecture very well, go through the details. And if you have liked the video, please subscribe to the official YouTube channel and definitely press the bell icon, which will give you every time the information for the latest videos. Thank you very much.